So hey guys, so coming up from the last video, we use exponents to find the integral in exercise 7.2. In this video, we're going to look at log of x, right? So functions that is a function of log. So something of f of x is equal to log x, all right? So interestingly, let me ask you something important. So if you watch the last video, all right, if I have integral of log of x dx, right? Or should I say, no, my bad. Or should I say integral of 1 by x? You know that it is log of x. Let's see. This is going to be our main focus today. This one. Okay? So here's the thing. The best thing about the log of x is whenever you see this question, whenever you see a question with anything like integral log of x, right? Remember, just equate this to t. So for exercise sample, so if you have a function f of x, okay, an integral function with f of x such that okay, you have log of x, just take log of x as the substitution value, okay? Or more formally, you can take log of x plus some value k, okay, or some value multiplied is equal to t. Because k is a constant, this will go to 0 when you differentiate, so don't worry about that. Okay, so let's do this. Okay, so remember this rule. This is very important. We're going to be applying this over here. Okay, all right. And why is that? Because okay, we're going to be applying that. And why is that? Because when we differentiate this, so let's differentiate, you would get, so k1 comes out because it's a constant. Differential of log of x is 1 over x, correct? And this constant goes to 0, right? This goes to 0. So plus 0 times d of x is equal to dt, right? So k1 times 1 over x dx is equal to dt, and therefore you need something of 1 over x dx is equal to 1 over k1 dt. Now this k1 is any constant, you don't have to worry about that, but see, you need 1 over x dx. Whenever you're integrating something with log x, they should be 1 over x 1 over x dx. So if you can find this, fulfill these two conditions. So if you have a function f of x such that you have log x, okay, and okay, so I should actually put more conditions, okay, log x and have 1 over x, okay, then apply this. Simple, very simple, and I gave you the reason why, right? So let's start with the first log question, which is question number 2. Okay, if you didn't understand, we'll be doing questions. I'll be doing the same type of questions. So as you watch, you will kind of understand. So let's say log of x the whole square divided by x. So what did I tell you? If you find log of x, check. Do you have log of x? Yeah, you do have log of x, correct? Correct? You have log of x. Do you have 1 over x? Yes, you do have 1 over x, because this is the same as integral of log, sorry, this is dx, x the whole square times 1 over x dx. So you do have, so you have this and you have this. So therefore they are integral. You can integrate it. Integrable. That's what I meant to say. Okay, so let's integrate this. So if we have both, so now all we have to do is apply this. So log x is equal to t. Then you differentiate it, because if you see the differential, that's why I tell you always keep your formula sheet. Look at this. Right? So 1 over x dx is equal to dt. 1 over x dx is equal to dt. So substitute these values. So you've got your two substitution values, right? So let's do it. So is equal to integral of, now log of x the whole square is going to become t square, and 1 by x dx is going to become dt. Now what is this equal to? How do you integrate this? Easy. T cubed divided by 3 plus c. So now what is your t? Right? Your t, substitute again. T is equal to log x. So which is equal to log of x the whole cubed divided by 3 plus c. Correct? So let's confirm this. So this is question number 2. Let's see the answer, whether we are right or wrong. Okay, so yes, we're right. We're absolutely right. Correct? And you obviously this is the absolute value of x, but it's up to you. Doesn't matter, whatever it is, put the absolute sign, absolute, whatever. Okay, so I think everyone got this. Okay, so next question. So we're done with question number 2. Now for these, so these white ones which I cancel were exponents. So let's go, I cancel 2. I'm doing red for logs. Okay, so that's there. Now logarithmic. Anyways, logs. That's a better way of saying it. Okay. Let's go next. Now, I hope you can find the next log question. Right? I hope you can find the next log question. So let's see. What's the next log question? The third. So the third question is the next log question. It is 1 over x plus x log x. Interesting. So you see log x, so integral, dx. But so let's follow the trick. So f of x such that you have log of x, and have 1 over x. So where are you going to get 1 over x? Okay, this is interesting. There's no 1 over x. But it's actually there, because if you see here, between the plus sign, x is a common factor in these two. X is a common factor. So I can take out x, which would result in integral of 1 over x times 1 plus log x dx. So this 1 over x is there, so I can say this is integral divided by 1 plus log of x 1 by x dx, right? So it's just shifted it this way just to kind of, so we have a 1 over x and we have log of x. So what do we do? So what do we take as the substitution? Not only log of x, you take the whole thing because it's a constant k. I remember I told you k. Always take k. When you differentiate, it becomes 0. So take the whole thing. You can take log of x, but then you'll have to do 2 steps of substitution. Anyways, it's your choice, but I would prefer this. 1 plus log of x is equal to t. So differentiate on both sides. What do you get? You get 1 over x dx is equal to dt. Now these two are your substitution values. So I'm highlighting them. Alright. So let's integrate them. So let's write the other version of it. So it's integral of 1 over t, interesting, dt. And so what is the integral of this is equal to, and what is the integral of 1 over t? Alright, let's look at that. Okay, 1 over t. So you'll use this formula, right? This one. Correct? That's the formula you would use. Okay, so which is equal to, let's see, is log of t plus c, right? Now log of t, now you have to substitute t back, so t goes back in here, which is log of 1 plus log of x, I think we do that, plus c, correct? So this is going to be a third answer. Let me confirm if I am right. It should be right. So just checking. Yes, absolutely right. Okay. So that is the answer. So we're done with question number 3. Okay, now before I get to the question, I hope you know what is the next log question, right? I hope you got the next log question. Let's see. Okay, let's see the next log question. So we're done with 3. 14. Anything before 14? No. So it's 14. So question number 14. Interesting. So question number 14 is 1 by x log of x raised to the power m. Remember, m is some constant value, is a set of real numbers, okay? So don't worry about that. 1, 2, 3, 4, whatever. So do you have log x? Follow the rules. You saw log x, right? F of x such that you have log of x. Yes, you do have log of x. Do you have 1 over x? Yes, you do have 1 over x, right? You do have 1 over x. Let me highlight that for you. Isn't this 1 over x? And you have log of x. Alright? So let's integrate this. So log of x is equal to t. 1 over x dx is equal to dt. Very easy. Now substitute. So again, I'm going to rewrite the equation. 1 over log x to the power m times 1 over x dx. Okay. Let's integrate this. Let's substitute. Let's substitute. I'm just rewriting this equation, right? So this equation is just rewritten over here. Okay. And like I said, I want to make this as easy as possible for us. All right. Okay. So let's equate this. So let's substitute the values. So 1 over t raised to the power m, and 1 over x dx is dt. So integral right? Now let's do this. So this is basically integral of t raised to the power minus m dt, right? M could be any value, we don't know what it is. So what is this integral? I think a lot of people get confused here. Don't worry, just treat it like a constant. So do what you do normally, right? So usually people get confused. So I'm going to do it plus 1 minus m plus 1. Okay? I think everyone got that. Which is equal to integral of t raised to the power minus m plus 1 divided by minus m plus 1 plus c. Now, what do we do? Alright, so we substitute for t. So what is t right now? T is log of x. T is log of x, okay. Oh, sorry, my bad. Forgot. This shouldn't be there. Okay. Okay, so this is log of x minus m plus 1 divided by 1 minus m. I'm just rewriting it, plus c. Okay, so this should be the correct answer. Let's check what is it. So this is question number 14. So I'm checking question number 14. Okay. Right. Correct. To write, okay, so they wrote it a bit nicer. Okay, you can, in the solutions, they've just interchanged that to 1 minus m. It's the same thing, looks better, that's it. Okay, if you came to the same answer as before, it's fine, don't worry. This is a good, if you substitute in this, that's more than enough, but this is, it looks neater. You don't want minus and plus first, but anyways, it's the correct answer. So I would suggest that you start finding your next integral, right? Find the next integral question. Okay, so this is getting easier, I think. So question 14 is done, right? So question 14. Oof, a lot of questions done. Okay. So let's see, question after question 14, which one is left? Which one is left? Let's see. Okay, so question number 29. 29. So now question number 29 is, this is an interesting one. Cot of x log sine x. Now this, would it be considered? Because the other logs you were with x, this is now with mixed in with trigonometry. So let's see if this fits. Okay, so this is integral dx, right? So that's what it is, right? I think this is not. So this is more of trigonometry. Okay, so I will skip this question for now because a separate video will deal with trigonometry. So I don't think I'm going to do that. So this is a mix of log and trigonometry. What I'm doing is anything like log x and 1 over x. So that's what I want. Okay. Okay. Any other log x? So question number 35. Yeah, question number 35. Okay. This should be right. Now, by the way, guys, I'm doing this as we go, so I'm not familiar. I'm just doing it as what I know. I'm using the techniques that I use, and I'm helping you with those techniques. So everything you see, I'm using the techniques that I've used. Okay, as simple as that. So let's go. 35 is 1 plus log x the whole square divided by x, which is kind of similar to, we just did something like, it's kind of similar to the second one, to be honest. It's just that one plus is added and the other one, yeah, is the same thing. Okay, but we'll do it anyways. It's the same thing as the second. So 35 is very similar to the second. Okay, so again, do we have log x, right? So f of x such that you have log of x, you have log of x, and you have 1 over x, correct? Right? Generally, when you see something put in squares or square roots or to the power 1/3, the whole to the power 1/3 or 2/3, that's generally what you want to substitute. That should be your first intuition, right? So whenever I see something in bracket to the power squared, I know I have to substitute this. Okay. Okay. So let's do this, right? You know that. Simple. 1 log x is equal to t. 1 plus log x is equal to t. 1 over x dx is equal to dt. Right? Got these two equations. Easy. Good. Now, so this becomes integral t squared over, not t squared over, I'm sorry, t squared. Let's rewrite the equation so that's easier for those parts. So the way I'm writing is log of x the whole square 1 over x dx, right? So we have this thing and we have this thing, just substitute over here. So this is basically this and this is basically this, so just substitute, right? These two, right? Which is equal to integral t squared dt, and so this is equal to, in what is t squared? T cubed over 3 plus c, which is basically what? So substitute t again back into the equation, right? Oh, sorry, my bad. What was I doing? Okay, yeah, sorry. Yeah, 1 plus log over x is here, so you substitute this. Sorry about that. Right? And this was over here. Correct. Now you substitute t back into this equation, right? Which is 1 plus log of x the whole cubed plus c. So 1/3 of this, right? Sorry, 1/3 of this. So let's check the answer. So question number 35. Oh, that's quite far. So I'm gonna check question number 35, right? 33. Yes, it's the right answer. So we're done with question number 35. Okay. Oh, okay, I knew 36 was the next. So anyways, I'll cancel it because it's right after that is a log question. Now this is, I think, the hardest log question, but it shouldn't be too hard. So let's see. Let's see how to do this. Okay, and delete. Okay. So 36. Sorry. 36 is what? What is question number? Okay, integral of x plus 1. Okay. X plus log x the whole square divided by x. Oh, okay, this is a very good question. I like this one. I like this. This is very good. This is a very good. So in the other case, this was a, so you have log x and you have 1 over x, but in this case you don't have a constant, right? Like constant k, you have something like this x. Interesting. This is very interesting. So how would we solve question number 36? Okay, so generally, like I said, now I don't know how to do this. Okay, to be honest with you, this is also a surprise to me. But let's use my intuitions, the things I've told you. If I see something with a square, generally I want to assume that this whole thing is going to be my answer when I substitute for t, and it is log x and it is 1 over x, correct? The other thing I'm also thinking is, what if I substitute x plus 1 is equal to t, and I'll have to double differentiate. This would be t minus 1, and so x plus 1 is equal to t, but then this becomes t minus 1, so it just becomes more bigger. So I don't think x plus 1, but I'm going to try this first, okay? It's most likely going to be this in my intuition. Okay, so let's try x plus log x is equal to t. So we differentiate on both sides, one with respect to x, the other with respect to t. So if we differentiate this, this would become 1, okay, plus 1 over x, the whole thing dx is equal to dt. Interesting. Right, so do we have this equation? Wait a second. So, interesting. Let's add this. What does this become? So if I want to make this okay, I think I'm seeing it right now. So this is also 1, so multiply by x, right? Because you want to make them like fractions, so it'll become x plus 1 divided by x dx is equal to dt. Oh, we got it. So I was right. So let's say you came till here, you scored some marks. So be happy about that. Okay, so basically we got it. So I'm rewriting this equation again in a different manner. So I'm writing it as, I can interchange these two, x plus 1 and x plus log x. So x plus log x times x plus 1. Okay, now because x is a molar, divided by x dx, correct? Simple. So I have my okay, this was a very lucky guess, I think, but it's the last question, so I'm hopefully right. So my methods still now have worked. They're giving you the right solution. So if you thought intuitively that you had to substitute this for t, very good, you were right. Okay, so let's do this, and let's highlight this and this. Okay, so to make it easier for you guys. Okay, so this is integral of t times dt, right? The integration part is so easy. It's just what you have to substitute that makes it complicated, right? You got scared of x plus log x and you solve this, but when it comes to integrating, it's just integral of t, which is t squared over 2 plus c. Again, substitute for t. What is your t value? Bring this value down to this. So this is equal, and equal, right? Is equal to, so what is t squared? X plus log x. X plus log x the whole square divided by 2 plus c. So let's check. Now this should be the next question. So am I? No. So the thing, it's a cube. Okay, so did I? Oh, it's x plus log x the whole square. I'm sorry. I am sorry. So this is squared. I didn't see. This is the issue when you rewrite questions. Okay, so this should be t squared, and this should be t cubed, and this should be 3, right? If I'm not mistaken. Okay, so I forgot to put this to, my apologies again. Squared, and then this becomes t squared. So you put t, so this becomes t squared using the substitution values on top highlighted in blue. Okay, and yeah, that becomes dt, t cubed over 3, and this becomes cubic, and this becomes 3. Okay, so silly mistakes. All right, silly mistakes. My apologies. Okay, so that was log of x, and I think log of x is very easy, right? So what have we done in 2 videos? So these questions, so if you see the ones cancelled in red with logx, so you can practice them. See, very few of them are. So most of them are trigonometry, right? So the vast majority. So how many are exponential? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 36 is exponentials, right? Which we did in the last video. And then we have 1, 2, 3, 4, 5. And then we have 5 out of 9. So this is, what do you say? So exponents type question is around 25%, correct? Because this is 1 out of 4, so 1, 4, simple maths. Log type is 5 divided by 36, right? So what is 5 divided by 36? Let's see. Getting in my calculator. So 5 divided by 36 is 13.9%, which is roughly equal to 13.9% here. Okay. Okay, so 14%, take 14%. I would rather take 14%. Okay, 14% of your questions are there. So how much is remaining? 25 plus 14 is 39. So 61% is trig based. Oof. That is really bad. That's really bad. So the remaining, so how much was that? Minus 36. So 22 questions are trig based. Okay, so don't panic. Okay, we're gonna look at some tricks to solve trig based questions, trigonometry based questions in the next video. Till then, I want you to go through these 2 videos so that it helps your intuition as to what to substitute or not. So I'll just repeat once more. Basics, very basics. Like in this question, whenever you see squared, or like if this was 2 to the by 3, or this was like let's say this was half or something, right? Generally, this is the substitution value. That's what I've seen in most cases, right? It's up to you. But those are your first intuition. Let me look at that, even if you don't know what to substitute, right? But I've given you the tricks for exponents and log-based questions. Go through them. And remember, the first thing that should go in your mind, the first thing as part of solving this exercise, is see which is encapsulated in a bracket and has a power. That's most likely going to be the substitution value. Okay, till then, take care, guys. Like, share, and subscribe. Feel free to comment, right? Feel free to comment, help others, point out my mistakes. If I made a mistake, point it out. That would be helpful, more informative. I can make those edits. Don't worry. So until then, take care, and thank you.